Congratulations, you have decided to watch a video on how to name binary compounds, rather than going through the frustration of asking the AI or Googling randomly without really knowing, is this the right answer? I'm assuming you're taking a chemistry course and you're going to have a test on this rather than just torturing yourself with chemistry. So there's no doubt that your professor is going to ask you questions like this on an exam. And if you're lucky, you have some choices. And if you remember some of the stuff that he taught you in class, which made perfect sense to you at the time, and now you're thinking, wait a minute, was that chromium trioxide? Do I use a prefix here? Or do I use a Roman numeral? Or maybe this is one of those compounds that doesn't even get a Roman numeral. You found yourself possibly with 3 good choices. Not bad. You got a 30% chance of making it, and maybe you will even pass. But you're better off paying attention to some very basic rules, all right? Now, if you're taking an online class, you can actually Google that, but you might have done that already while you were studying, and you found that AI and Google don't agree on things like this. And I've purposely picked chromium trioxide or chromium 6 oxide or ammonium monochromium, whatever it's called. But there are many answers, right? So this is very confident. AI confidently tells you this is chromium trioxide, and then you put this into your homework manager, and the homework manager tells you it's incorrect. Okay. Then you put in the second answer here, which is chromium 6 oxide, and that is the correct answer that your homework manager will like. But you still don't know when to use tri and when to use 6. Now, the simple answer is ionic compounds, which are metals and nonmetals. They potentially have Roman numerals, but not always. And covalent compounds use prefixes as tri. Now, there's a reason why chromium trioxide is sometimes called chromium trioxide, but on your level, that's not even an option. It's a metal and a nonmetal, and because chromium can have different charges, you have to use a Roman numeral. See, even Wikipedia here, if you're using Google, will give you chromium trioxide rather than the proper IUPAC name, which is what we are looking for when we teach you this. The International Union of Pure and Applied Chemistry here, IUPAC. Those are the kinds of naming that we're looking for. But even if you input that into your AI, you still are told that this is chromium trioxide. And then you're giving a whole bunch of different answers here. So what's going on? Let me start from a very basic perspective. As I said a second ago, or 38 seconds ago, or now it's 42 seconds ago, who knows, who can keep track of this stuff? There are 2 types of compounds that you want to watch out for. Covalent and ionic. And so this thick line here divides the nonmetals from the metals. And when you have 2 nonmetals, such as carbon and oxygen here, so clearly both of those elements are to the right of this line, so they're both nonmetals. And when they combine, they can do that in different ratios. Now, carbon and oxygen, to my knowledge, only has 2 compounds, carbon monoxide and carbon dioxide. So they're sharing electrons, so whichever way you can connect these and come up with a proper formula and a proper way of sharing where all these elements have 8 electrons, you have yourself a compound. The 2 that are possible here are carbon monoxide and carbon dioxide. So we use prefixes to indicate the number of elements in the compound, or the number of atoms in your formula. In this case, dioxide for 2 oxygens or monoxide for 1. The other possibility is that you have a metal and a nonmetal. And so when electrons are transferred from the metal to the nonmetal, like sodium here will give up its electron transferred to chlorine, and you now have charged particles. Sodium ion and chloride ion, we name that simply sodium chloride. So that's the only possible combination there is in a 1-to-1. So we don't use prefixes and we don't use Roman numerals. Now sometimes you get a charge. You get a metal where you can have different charges, and those are usually the transition metals, but sometimes also some of the lower lying main group elements that can have different charges. And then you can have different combinations. You can have a 1-to-2, a 2-to-1, and because it's ionic, instead of using prefixes, we use Roman numerals that indicate the charge of the metal. Okay, but the bottom line is this is two different types of compounds, covalent and ionic. And then occasionally you're asked to come up with something like this: calcium and sulfate. Now, sulfate is not an element on the periodic table, but because a metal is involved, most likely this is an ionic compound. And so sulfate has to be something different, a charged particle, a combination of some sort. We call this a polyatomic ion. It has the formula of SO4 and it has a predetermined charge of 2-. And when it combines with calcium, which also has a predetermined charge, they combine in a 1-to-1 ratio to form something called calcium sulfate. So back to these polyatomic ions, right? They are, as you can see, we have phosphorus and oxygen, so those are both nonmetals. So they share electrons, but because they have a charge, an overall charge, they're ionic, and so they can combine with other metals or other polyatomic ions that are positively charged. So we treat them the same way we would monoatomic anions, like nitride, right? So we know that nitrogen here, which is 3 away from neon, it will pick up 3 electrons, right? 7 electrons plus 3 makes 10, right? So this is kind of the driving force here to become noble gas-like. Fill that up. So nitrogen will gain 3 electrons. If that doesn't make any sense to you, just simply remember the charges are here. -3, the +3 was for gaining 3 electrons, which then means you have a -3 charge, right? So this is +1, +2, +3 if they're metal, and then -1, -2. So nitrogen will be -3, and it will combine with something like sodium in a 3-to-1 ratio, because sodium has a +1 charge and nitride has a -3 charge, so I need 3 to balance that out to make this overall neutral. Na3N. And phosphate does the exact same thing. It's the exact same ratio, 3-to-1. So then we write sodium 3, and instead of N, single N, we write the formula for the polyatomic ion. Sodium phosphate is that name, right? So polyatomic ions, if you're in my class, you're going to be given this chart. If you're in somebody else's class, you may be given a number of polyatomic ions that you have to memorize. There is some virtue to that, because then you will know and recognize these polyatomic ions rather than me. I'm giving you the chart. You just have to know and then look them up, right? So if you are given a name or a formula that is, let's say you have something like strontium and then Cn parentheses 2. Okay, that's a little sloppy. If you have more than 2 elements in a formula, that means a polyatomic ion has to be present. And it's got to be the 2 nonmetals, right? So strontium is a metal, so C and N has to be a polyatomic ion. And the parentheses just simply mean we have 2 of them. We have 2 cyanides. We find a cyanide, and a strontium. And if you go back to the periodic table and you look up where strontium is, you know that it's +2. And then by default, you understand that you have 2 negative charges on each of the cyanides. That's why that is. But you don't even have to memorize that. You just go find that CN and find the name. Or if I provide you with a name like, aluminum cyanide, then cyanide is a polyatomic ion. You can look it up, you can find the formula, and you can then provide the formula or the name vice versa, depending on what we're asking. And just to transition, and unfortunately, there's a lot of similarities, and so this is where confusion comes from, I think, but when we follow those 2 naming schemes, right? So the 2 different types of compounds, once again, are covalent and ionic. If you have an ionic compound, you follow a certain rule. You always name the first element, followed by the second element. If it's a single element, we add IDE to it. So there's sodium chloride. But we also have chloride here for the covalent one. So So these are all chlorides, for example, right? So that appears in covalent as well as in ionic. The thing that's unique for ionic is the Roman numerals. Okay, so iron 3, you'll never see a Roman numeral for 2 nonmetals. And the polyatomic ions, right? They're not here. We don't have a polyatomic ion here. But polyatomic ions is only here on the left for these ionic compounds. You're not going to use prefixes for polyatomic ions, which means they have to be ionic. You do use the prefixes, and I think some of the confusion is the prefixes means the number of atoms, whereas the Roman numeral is the charge of the metal exclusively. And then there's this question of when do we use a Roman numeral and when do we use a prefix? So this summary slide kind of tells you this, right? It always indicates how many atoms there are for each atom in a molecule. This is a molecule. There are 2 phosphorus atoms, so we call it di, and 5 chlorine atoms, so that's called penta. And then the elements are, the first element is just the name from the periodic table. Phosphorus is listed as phosphorus. And the second element, chlorine, it gets the ending IDE, chloride. So this is diphosphorus pentachloride, which, by the way, I made up. It doesn't exist. Isn't that fun? The Roman numerals appear when you can have a metal that can have different charges. Like iron. Iron can lose 2 electrons or 3 electrons. It can be +2 or +3. So they can't both be iron chlorides. Right? The other formula would be FeCl2. This would be iron 2 chloride, indicating a +2 charge on the metal. So the Roman numeral here in green reflects the charge of the metal, in this case the transition metal. Let's take a closer look at which elements or which metals specifically get a Roman numeral. This is a handy-dandy chart for predetermined charges. We know that all of the main group elements or metals here will have a +1 or a +2 charge, never +3 or anything other than that was listed here in purple, right? So all of the purple ones are +2. And so here's a couple more also in purple with a +2 charge, zinc and cadmium. And it can be, you just have to memorize that zinc and cadmium are going to be +2. And to make things more complicated, this periodic table indicates that silver also just loses 1 electron for whatever reason. We can get into detail. I'm happy to make a recording on why it does that, but our focus is naming. Everything else, all the metals that are yellow shaded or orange, whatever this color is, they get a Roman numeral. So this is all of those here, all of those metals. If you see them in an ionic compound bound to a nonmetal or a polyatomic ion, you are going to have to use a Roman numeral. Okay? So let's go through the 2 rules just because for practice, or because not, or just pause or close it out and get my analytics only to 60%, which is better than what I normally have. I have like 3% normally. People start clicking on it and then they click off. But here we go. Don't want to waste your time here. So here are the rules for naming simple compounds, covalent compounds, right? So we are sharing carbon and oxygen, sulfur and oxygen, lots of oxygen here. Here's nitrogen, fluorine, all those are nonmetals. And the rules are actually so specific that it tells you which element goes first. Is it H2O or O2H, right? Here we list the hydrogen first. Here we list the nitrogen first. And it's not random. There's actually a reason, right? It goes by, in this order, group 3, 4, 5, then hydrogen, then 6 and 7, and then last is oxygen and fluorine. You don't ever have to worry about it. You're either going to be given the proper formula or the name is going to indicate which element is named first. I just kind of wanted to show it to you because, right? So these are covalent compounds, so we always use the prefixes, and the prefix mono is always used or is sometimes used for one of these elements, but only the second one here, right? Not the first one. This here is just simply silicon and then dioxide. So the first element, if it's by itself, it does not get the Roman numeral. Now the next one is nitrogen and oxide, and so it gets a prefix for each, right? So di is 2 and tri is 3. Now I tried to get one in of each of these, like 2, 5, 4, 6. You might get to see 7 and 8. You're not going to get to see those. You don't have to memorize those. Just mono, di, tri, tetra, penta, and hexa. So the next one here is nitrogen and then fluoride. And I didn't mean to highlight to make this in red, but that's okay. So tri is for 3. Here we have nitrogen oxide, and the two prefixes are di and penta. And then finally I have carbon and bromine, and 4 is tetra, so carbon, tetra, bromide. One other quick thing here. Okay, so in the case of pentoxide, you might want to say pentaoxide. If you have 2 vowels in a row, the A and the O, you take the A out, so this turns into pentoxide. Your homework manager may be tricky about that, so keep an eye out for that. And then here we have the rules for the ionic compounds. So those that are obtaining a Roman numeral, if you look at the periodic table, calcium always is +2. Iron can have different charges. Lead can have different charges. Lithium is always +1. And then these are both polyatomic ions, ammonium and phosphate. And those you have to look up. But the reason I wrote those charges up top is because they are predetermined, so we're not going to use a Roman numeral. So the first one is simply calcium and then bromide. This one here is just lithium and then sulfur turns into sulfide, so SULFIDE. IDE is a single element, and here you have to just look up the polyatomic ions. This is ammonium, this is phosphate, so this is ammonium phosphate. And then here we have to have Roman numerals for the iron carbonate and the lead hydroxide. How do I know what charge the iron is? You look up what this is called, and you look up the charge, and you find out it's called carbonate. And you find that this has a 2- charge. Since these are in a 1-to-1 ratio, the iron has to be +2. So this is iron, Roman numeral 2, corresponding to that charge, carbonate. Do the same thing for the OH. You go look it up. It has a -1 charge. You recognize that there's 2 -1 charges bound to this lead here, which means it has to be lead 2. So this is going to be lead, Roman numeral 2, hydroxide. So there's a lot for you to learn. Recognizing polyatomic ions, understanding the charges, how to determine this, and then, it's not as easy as it looks. And I always present those things and make them look easy, and then it's just not fair to the students. So hopefully this helped you. Good luck on the exam.